Dream to become the next Sir Isaac Newton or Albert Einstein? Learn from the master. Refath Bari. Watch his videos to achieve your dream.
Welcome to Special Relativity Lecture number 18. Today we're going to be continuing the problem we've been doing for the last 3 lectures, which is, let me just give you an overview. So we had what? We had 3 dimensions, and we had a charge Q at the center of a sphere, and that sphere was our surface, right? This was our sphere. And we wanted to find the electric flux coming out of this charge Q out of a section of this sphere. So we took a very small section of this sphere and we decided to find the flux through this section of the sphere. Okay, so you can see I just shaded out a part of the sphere. Hopefully you can see that. Okay, so last lecture we found the area of the differential surface of the sphere. And what was that area? If you don't remember, then let me just go ahead and write it down. We found that the area of this differential surface, ds, it had a base of RD theta, and what was its height? Its height was r sine theta d phi, right? So if you treat this as a rectangle, its area would just be base times height. And what is base times height? R times r is r squared sine theta, and our differential constants are d theta, d phi, right? That was all old stuff. We did that in the last couple of lectures, okay? Now the new stuff is going to come, and that new stuff is just computation. We're just going to take the integral now. And let me first and foremost write the integral down for you. It's going to be the integral of what? The electric field dot the normal vector times the surface area of our sphere. Okay? So this is going to be a closed surface integral. So let's go ahead and compute this. So what I'm going to do is, first and foremost, we're going to plug in for this dA here, because we already know what our area is. Our area is r squared sine theta d theta d phi. So let's go ahead and plug that in. Okay? So we're going to have double integral, right? D phi, and what integral is going to be theta. Okay? And then we can just we know that this is a sphere, right? So the normal vector will be parallel to the electric field. So you don't have to worry about cosine theta or anything. You can just go ahead and write down the electric field, the magnitude of the electric field, times instead of dA, we're going to replace dA by all of this mess. R squared sine theta d theta d phi, right? Okay, well, what is the equation for the electric field? The equation for the electric field is, hopefully I remember it, otherwise that would be embarrassing. The electric field is kq over r squared. So what is k? K is going to be 1 over 4 pi, the permittivity of free space. So that's k, and then I have to put q over r squared. So all of this is the electric field, right? Okay, and then I have to multiply it by this young r squared sine theta. So r squared sine theta d theta d phi, right? So now you can, hopefully you see that a few terms cancel out. And what are the terms that cancel out? R squared and R squared cancel out. So now I can just go ahead and write this over here. So the double integral, one is going to be phi, one is going to be theta, but I'm going to have what? I can pull out, what can I pull out? Isn't this a constant? So I can pull out the constants. So I'm going to put them outside of my integral. So I'm going to put q over 4 pi epsilon. And then I'm going to have my double integral, and sine theta, d theta, d phi. Sine theta, d theta, d phi. So now we just have to evaluate this, right? So remember this is theta 1, so theta 2, phi 1, phi 2. Okay, so how do we, what's the integral of sine? Anyone have an answer? What's the integral of sine? Integral of sine is?
Cosine.
Negative cosine. So we can put down the negative in the front because it's a scalar. So negative, put down your constant, 4 pi epsilon, and then we can write down the integral, phi 1, phi 2, and then we can write down cosine of theta from what? From theta 1 to theta 2, d phi, right? Okay, we're almost done, right? So now all I have to do, what do I have to do? I don't even know. I just have to evaluate this definite integral. So let's go ahead and do that. So let's write our constants here, q over 4 pi epsilon, and then I'm going to write my integral, but be careful. This is a constant. If we're differentiating in respect to phi, we can treat this as a constant. So we're going to go ahead and treat that outside. So we're going to write cosine of theta 2 minus cosine of theta 1. Okay, and then we can write our integral. I'll write my integral on the next line. So the integral from phi 1 to phi 2 d phi. And the integral of a derivative is just whatever function you're dealing with, right? So we'll just go ahead and write this down. So what will our final answer be? Our final answer will be q over 4 pi epsilon naught times all of this garbage, cosine theta 2, cosine, let's write it in a different color, cosine theta 2 minus cosine theta 1, and of course we're going to multiply that by phi 2 minus phi 1. So phi 2 minus phi 1. That, my friends, is going to be the electric flux through a section of the sphere, right? So this over here is going to be our final answer. Okay, so thank you for watching, and we'll see you next time.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.